Hi, Chris Good here, and this is a solution to independent groups, ANOVA practice number 2, states history. Students completed high school senior level standardized U.S. history exam. Major for students was recorded. Data in terms of percent correct was recorded below for 32 students. Compute the appropriate test for the data provided below. It's ANOVA, guess what? They already did the sum of squares here. I am going to show you how to do it in Google Sheets. So I've already calculated the means, the t's, the n's, g squared, and degrees of freedom, both between and within. So let's organize these just a little bit and bold them. Okay, bold them, thank you. And we're going to first get sums of squares for each treatment, okay? So sum of squares is going to be the sum of the square deviations of each one from their mean within the group. So let's do this. We'll do deviations for all 4 of our groups, and that's just the score minus the mean for that group. But let's reference that mean all the way down and copy that. We're just going to do this for all 4 of our groups. So subtract for the business people, subtract their mean, and make sure that it stays the same mean as you go down the column. Alright, we'll paste those. Some deviations are positive, some are negative. That's why the mean's the mean. Did I miss one? Oh, I skipped education. Ooh, okay. Let's do, oop, there was a problem. There certainly was. Okay, let's do this. Education was the education score minus the education mean. And we want to use the education mean for all our education scores. There we go. I guess I did do that one right. So then business management minus business management mean. And behavioral studies is behavioral social science minus the behavioral social science mean. And we'll do the same thing for fine arts. It's a fine arts score minus the fine arts mean. Aren't you glad you're doing this in Excel and not using your calculator? That would be tedious, and these numbers are very large. But if you want to watch me do it using my calculator, see this other video on my YouTube page. Okay, those are deviations. Let's do deviations squared, right? Let's square all these deviations. Education deviation squared. Okay. Education deviation squared. And then we'll do that for all these groups. Okay, now we can do sums of squares for each one of these groups. That's just the sum of the education squared deviations, and just copy and paste that all the way across to get our squared deviations for each group. Now we can go do sum of squares within treatments, but let's do sum of squares between treatments first. Remember, that's going to be the sum of your t squares divided by n for each group, right? And let's do t squared over n for each group. And let's do, oh, we've already got g squared. I think we've got everything that we need. So t squared is going to be t squared, and do that for all 4 groups. And then for each one, divide your t squared by n, right? And then we're going to do sum of squares between treatments is just equal to the sum of these minus, this is the quantity g squared over big N, oops, which is, I guess it's just the sum of the little n's, right? That's what big N is. I could have counted them too. Okay, that's sum of squares between treatments. We can do sum of squares within treatments. That's just the sum of the sums of squares for each treatment. And now we can do mean squared for each one. We need our degrees of freedom, which I already calculated for you guys earlier. Mean squared between is sum of squares over degrees of freedom. Mean squared within is sum of squares over degrees of freedom. And now we can calculate f as mean squared between divided by mean squared within. Wow, f is really, really small. Look at that. Now I didn't do my null hypothesis of mu1 equals mu2 equals mu3, but, and I also didn't look up f crit for 2 and 3. Wait, that's wrong. Degrees of freedom between treatments is that's 4 minus 1. That's 3. That changes a few things, but our f crit is still 3 and 29 degrees of freedom. This was big N minus K. Okay, that's 4 and 29 degrees of freedom. If you go up to page 2 of your F table, degrees of freedom in the numerator 4 and 29 degrees of freedom. Oh, it was 3 and 29 degrees of freedom. For an alpha point of 5, it's 2.93. We're far below that, and so the decision here is to fail to reject the null hypothesis. We did not, let's capitalize that, we did not detect a significant difference among these three means. F of 3 and 29, f of 3 and 29 was 0.0497. Let's round that to 0.05. With P, don't get confused, P was actually greater than 0.05. And that's it.